After studying 56,000 stars, scientists discovered that our sun is a bit unusual. All along, astronomers believed the sun was just one of the hundreds of billions of stars in the Milky Way, an ordinary yellow dwarf star, quiet and unremarkable since its birth 4.6 billion years ago. But after analyzing 56,450 stars, astronomers found something odd about the sun. Simply put, it's not as active as other stars of the same age. Instead, it's more stable, more consistent, as if it's deliberately trying not to disturb Earth or the evolution of life, almost as if it were designed that way. These 56,450 stars data came from NASA's Kepler telescope and the European Space Agency's Gaia mission. While Kepler observed 160,000 stars in search of planets, it also recorded their brightness variations. Gaia measured the positions, distances, and chemical compositions of 1.7 billion stars. Astronomers selected 56,450 G-type main sequence stars similar to the Sun and gave them a thorough checkup. The results were surprising. Even though the Sun is considered the template for G-type stars, in terms of activity, chemical composition, and stability, it stands out from its stellar siblings. First, many giant stars produce flares 100 to 1,000 times stronger than the Sun's, and they happen far more frequently. In 2020, the Astrophysical Journal analyzed 369 Sun-like stars and found that they are, on average, 5 times more active than the Sun. With much larger brightness fluctuations, our Sun, in contrast, appears far too quiet. Its strongest flares are merely average compared to other stars. The second oddity is the Sun's chemical composition. Typical yellow dwarfs are made mostly of hydrogen, helium, and trace amounts of heavier elements, but compared to them, the Sun's elemental makeup is unusually low. For instance, it has more than half as much metal content. Some scientists even suggest the solar system might not be native to the Milky Way. It may have arrived billions of years ago, after a galactic collision between the Milky Way and another galaxy. The third anomaly is the Sun's stability. Kepler observed that among the 56,450 giant stars, many show dramatic brightness fluctuations. Some cycle within just a few days. Some pulse like a heartbeat, but the Sun is steady as a rock. Its brightness varies by only 0.1%. And its 11-year cycle runs like clockwork. Such extreme stability is incredibly rare among stars of its kind. With all three factors combined, Earth's journey of life, which began 3.8 billion years ago, has gone largely undisturbed. Even today, aside from a few solar flares, human civilization has faced few threats from the Sun. Then again, this might just be wishful thinking by Turkey scientists. After all, we've only been observing the Sun for a few decades, not even a second in its 4.6 billion-year lifespan. Maybe the next phase of the Sun's life will bring it in line with other active stars. Frequent brightness shifts and solar flares could disrupt life on Earth, perhaps only when we achieve controlled nuclear fusion and build our own artificial sun can we finally escape our dependence on the Sun's natural light and heat. Then, under the glow of a man-made star, human civilization could reach any planet in the solar system, even the farthest edges beyond.